All right, so on here we did 9 times 14, that gave us 126. And then we did 9 plus 14, that gives me 23. Okay, so on number 5, what's negative 15 times negative 7? And then if I take negative 15 plus negative 7, what do I get? Negative 22. On the next one, they don't give you the other number, but they do give you what they add up to. So what plus 1 would give me 10? 9. And then 1 times 9 would give me what? Yep. Okay. On the next one, they don't give me the two numbers that multiply to give me 78, but they give me 78 as the product. So what times 13 would give me 78? How'd you get that? 78 divided by 13, that gave you 6. Now, if I add 6 plus 13, what does that give me? 19. Are there any questions on how to do this? Okay. Lord Almighty. Okay, go ahead and take a look at the little foldable I gave you that has the rational, irrational stuff on it. Okay, so when you fold this, it's gonna look like okay. So when you fold this, ladies and gentlemen, I know math's so exciting. Okay, you're gonna fold these papers together, or this paper together, where you have the overlap of like numbers right here. So you're doing it like the one that says rational, irrational on it, and you want to fold it in like this. Okay, so it's a little foldable. No, rational, irrational. Okay, so go ahead and do that. There's like little lines on the one side that'll show you where to fold it. Okay, so we're gonna talk about rational numbers. So on your test, really quick, at the very end, it asks you about rational and irrational numbers. So we got to know what those are. This is always the one that everybody forgets about on the final exam. There's always one question about this stuff. So the definition of a rational number is a number that can be expressed as a fraction, where the numerator and the denominator are integers, and the denominator cannot be equal to 0. All right, so characteristic is that the decimal form of each rational number can either be terminating, or repeating with a pattern. So the decimal form of each rational number can either be a terminating number or a repeating with a pattern. What does terminating mean?
Just scratch it out.
So stop, right?
Yep. Like someone presidential election getting terminated.
Oh, okay. Okay. So examples of this. If we have negative 5.4, we see that the decimal is terminating. Yeah. Okay, so that would make it rational. On the next one, we have the square root of 100 divided by 2. What's the square root of 100? square root of 100? Nope. Try again. 10. And then we're going to divide it by 2. So that's going to give us 5. So since the fraction is integers, it's going to be rational. On the next one, this little symbol right here means repeating. Okay, so the decimal has a pattern. Then that's what makes it rational. Okay, a non-example of a rational number is pi divided by 2. So if I go into Desmos and I type pi divided by 2, notice how this is not a repeating number. There's not a pattern there, and it's not terminating. It goes on forever, right? So this number continues on even if we don't have, like it keeps going. Okay, so with that being said, move it back, not it. There it is. Okay, so since this is not an integer in the top, pi over 2 is not rational. So an irrational number is a number that cannot be expressed as a fraction. The two common irrational numbers include numbers that involve the value of pi after the expression has been simplified, and the square roots of not perfect squares. So this also includes roots, cubic roots. All right, so some examples of these. So right here we got 3 pi divided by 5. This involves pi, which is not an integer. Okay. On the next one, the cubic root of 2, it's not a perfect cube. So it's going to be irrational. The square root of 5 is not a perfect square. So it's going to be irrational. A non-example over here would be 4 pi divided by 2 pi. Well, these would cancel. And we know that 4 divided by 2 is going to give us 2 over 1, or just 2, which are integers, which makes it rational. So we're going to talk about the real number system. So back in the day, your teacher, back in elementary school, your teachers started talking about the natural numbers. Then they moved to whole numbers. Then in middle school, you started talking about integers. And then now you're starting to talk about rational and irrational numbers. So, example, natural numbers are going to be like 1, 2, 3, 4, etc. Okay. Your whole numbers So your whole numbers are going to be things like 0, square root of 25, 6. Your integers are going to be something like -3, -10 divided by 5, -4. And then your rational numbers are going to be like -2/3, 1/2, 5/8, 0.37, 0.75, 0.31 repeating. And then irrational is everything that isn't terminating. On that same paper, it has some vocab up at the top. And there's like 3 blanks, right? On the first one, it says a number that cannot be made by dividing two integers. What's a number that cannot be made? What's a number that cannot be made by dividing two integers? Mm-hmm. So it's the same paper. It's the same paper. Up at the top, it says vocab. Okay. And it says a number that cannot be made by dividing two integers. So it's above that box. Guys. Down at the bottom of your paper, it says the sum of rational and irrational number is always going to be rational. So on your document, down at the bottom, it says sum of rational and irrational number. You're going to write always rational. That same document. No, the same document that you were just writing on. Down at the bottom, there are words. Then it says the product of a rational and irrational. Okay, that's always going to be rational. The sum of rational and irrational is always going to be irrational.
See, way worse.
And the last one, the product of a non-zero and of rational and irrational is always going to be irrational. I would maybe write this off to the side. Here's some examples. For instance, on the first one, you could have added 7/8 plus 6/8, and that would give you 13/8, and we know that that's rational. If you do the product of two rational numbers, like 2/3 times 2/3, that would give you 4/3. Again, that would give you a rational number. All right, and then the sum of a rational and irrational. An example of this would be pi plus 0. That's going to give me pi. And then the product of a non-zero, rational, and irrational is going to give me, so if I multiplied something like 4 times the square root of 10, that would give me 4 square root of 10. So is number one rational or irrational? It's rational. It terminates. Now, number 2, is it rational or irrational? So I'm getting mixed feelings. Okay, convince me. Why? It's repeating. So is it rational or irrational? It's rational. Look back at your folder or your little foldable. Now, square root of 2, does that terminate or have a repeating pattern when you plug it in your calculator? Square root of 2. So is there a repeating pattern here? No. So what is that called? Okay. And then 4 divided by 5, is that rational or irrational? Rational. Okay. So on 5 and 6, we're using some of our skills from last week. So 5 and 6, you're simplifying that and then deciding whether it's rational or irrational. So go ahead and take a moment, do that, and we'll talk about it. All right, so on number 5, when we multiply radicals, remember we can only multiply the insides together and then we can multiply the outsides together. So what's 50 times 2? 100. Can we take the square root of 100? Yeah. What is that going to give me? Is that rational or irrational? Rational. Number 6, we can't add those two things together. So if we just plug this into our calculator, we have 7 plus the square root of 28. Does that have a repeating number or does it terminate? No. Does it repeat? You see why? So it's not like 2, 9 keeps going. If it's random numbers over and over again, then that's not repeating. So this is going to be irrational. But we want to simplify this. Okay? We want to simplify this. So what can I take 28 and break it down to? What factors are 28? 7 and 4. And then 4 breaks down into 2 and 2. So I can pull out a pair, and that's going to give me 7 plus 2 square root of 7. Here's the new part, okay? So last week, we talked about simplifying radicals. So we've got 2 plus the square root of 12, and then we're dividing it by 6. Now, what you want to do is you want to simplify the radical, and then we're going to do one more extra step since there's that line underneath and then a number down top below. So what can I break 12 down into? 6 and 2. Yeah. And then what can I bring 6 down into? Okay. Since there's a 2 that repeats, I'm going to rewrite it like this. 2 plus 2 square root of 3 divided by 6. Gotta multiply. Now, here's the part that has been added on. Since all of the numbers that are outside the radical are divisible by something, we can simplify. Okay? So for instance, we have a 2 and a 2 and a 6. So what are they all divisible by? 2. So if I divide 2 divided by 2, what do I get? And then if I divide 2 divided by 2, what do I get? We're going to keep that radical right there as well. Not going to mess with him. 6 divided by 2 is going to give me 3. Then that's my simplified form. On number 8, we have something very similar. Can we take the square root of 81 though? So square root of 81, 9. So this is going to be 5 minus 9 divided by 2. Well, what's 5 minus 9?
-4.
A -4 divided by 2. So sometimes this turns into a whole number, okay? And sometimes it does not. All right, so on number 9, we need to simplify that square root of 50. So what are 2 factors of 50? 25 and 2. And that 25 can break down into 5 and 5. So we can pull out a 5 and we're left with 2 underneath. Now, is there a greatest common factor for all the numbers that are outside the radical? So 4, 5, 7. Do we have a greatest common factor with those? No. So this is it. That's the simplest form. Okay. Now, on number 10, we have -2 minus the square root of 20 divided by 2. What are factors of 20?
10 and 4.
I heard 4 and 5.
I mean, 2.
And then I can break 4 down into 2 and 2. So this will become -2 minus 2 square root of 5 divided by 2. Now, is everything on the outside divisible by the same number? Well, there's 2's all out there, so I can divide everything by 2. And so that's going to give me -1 minus the square root of 5. And we don't have to put the 1 on the bottom. We can just leave that off.